All right, welcome everybody. Always takes a minute for Zoom to connect everybody's audio, but I would like to say I'm very excited for this morning's edition of Climate Connection. We have some absolutely fantastic guests today. As you can see from the screen and as you would have got from the registration, this is the energy edition. So we've got some great representatives from the energy industry with us here today. Before we get started, I would like to mention this event will be recorded. And if you do have any questions, which we highly encourage, do jump into the chat and write them there, and they will be passed along to the panelists when we get to that section of the morning. I would also like to acknowledge that while we are represented from folks across the country, I myself and Foresight's offices are located on the traditional unceded territory of the Musqueam, Squamish, Tsleil-Waututh, and Tsawwassen nations. To give you a little rundown today, we'll be doing some welcome and some introductions for the first 10 minutes. Then we'll move on to that industry expert panel, as well as a Q&A. And finally, we're going to be moving to some breakout rooms at noon, where you will get to talk to some of those panelists and dig a little bit deeper and ask your own questions of them. So while we will have a moderated question and answer session moderated by the fantastic Shannon Bard, we will also have a chance for you to jump in there and talk to these folks a little bit more. Again, the goal here is to bring together industry and academia and early stage innovators and provide some context around some of the challenges that the industry is facing so that we can solve them, which is ultimately what Foresight is about. We're Canada's largest clean tech accelerator. We are about delivering technology solutions to the challenges that industry and the climate face. We do this in a number of ways, including our sector-specific activities, of which obviously today this is one. We focus on 5 main sectors: energy, water, carbon, ag, and the biocircular economy, as well as supporting clean tech ventures more broadly. We're very excited about our partnership in energyNEXT with Unique Ventures. I do see one of our friends from Unique is on the line today, so thank you very much for them in that partnership. They bring their international experience as well as their connections down in Houston, another great energy hub for North America, to help ventures explore, get contacts, and move their technology to commercialization as quickly and effectively as possible. I'd like to take a moment now to introduce Tony B. from the Clean Energy Research Center to talk a little bit about the work they do. We're very excited about our partnership with Foresight, and part of it is with CERT. So Tony, would you tell us a little bit more?
Okay, thank you, Stephen. So I'll just give you a very, very high level introduction about what we are doing at the UBC Clean Energy Research Center. So UBC Clean Energy Research Center was established in 2005, has been 15 years. So we have landed and 2 more CFI funding that is for the transport future, looking into the fuel cells and the transportation charging stations. Also about refining and the research innovation center that look into the pilot scale testing of the bio refining or bioproduct and bioenergy technologies. So currently, we also have a UBC bioenergy research demonstration facility. Has a phase 2 will be completed very, very soon. Also a campus energy system, as well as some of our research activities with the IP innovation and then the BC pulp paper industry about utilizing the bioenergy to decarbonize the industry. Also, we have a China-Canada bioenergy network collaborating among almost 75 PIs to look into the technology development, also deployment in both Canada and China. So we have divided our research into 6 clusters. So one looking into the bioenergy and the biofuels, another one looking into like the photochemical process or systems, including the fuel cells, batteries, and then energy storage. As well, we look into the urban energy systems, including the district energy heating systems, as well as the transportation. Also, we look into the decarbonization, including carbon capture utilization, as well as how to mitigate the other air pollutant from the energy systems. Also, we look into the data analysis, optimization of different energy systems, last but not least is looking to like the life cycle analysis to quantify the carbon footprint or the environmental footprint, as well as the policy research, to support our transition of the BC into the clean energy system in the future. Overall, we try to become a global leader on the kind of the clean energy development research and demonstration. So again, we welcome all these industrial partners or the government partners who will value our kind of the research facility, as well as our researchers to work together to develop the next generation clean energy technologies and products. Thank you very much.
Tony, thank you very much for what is obviously years of dedication and hard work to move some of these technologies forward. And we're happy to see some of them, like hydrogen, entering the market and finally getting the light shone on them that they deserve. Moving along, I'll let Shannon talk a little bit about E at UBC, our wonderful partner that helped us kick off this series.
Thank you so much, Stephen. So Entrepreneurship at UBC is a program. It's an incubator and accelerator that helps support members of the UBC community to develop ventures and to launch them. And a lot of our work is around clean technology. I lead a portion of that called the Climate Venture Studio, which really focuses on finding ways that we can accelerate taking science-based research and engineering-based research and making impact with that through venture building in an accelerated fashion to address the climate emergency. And so what I wanted to welcome some of the people that are on the call today is we have a number of different ventures that are not only from UBC, but from academia across the nation. We have people from Queen's and a number of other universities that are here, as well as researchers that are coming as well. And we wanted to have a venue where we could have both people that are actively involved in venture building, but also researchers who might be thinking about what their next steps might be. And that this would be an opportunity to hear from the different panelists that we have that are coming across multiple sectors in the energy space about what their really pressing problems are, and that could be informative both for customer discovery for our ventures, but also for our researchers who are thinking about what direction their research could go to help solve some of our most urgent problems around climate solutions. So Stephen, should I just go straight into the panel?
Yeah,
fantastic.
I think that's what everyone's waiting for.
Fantastic, let's do it. So we've got 4 panelists that are here today, and what we're going to do is we're going to ask each of them to talk about what their pressing problems are within their field, and we'll go one from another. But what we would ask you to do, really encourage you to do, is please use the chat. What I'd like you to do is that when you have a question that comes up as each of the panelists is speaking, please put that question in the chat as you think of it. Then when we've had the 4 presenters finish, then we're going to have a discussion and use your questions as a way to jumpstart that discussion. So I really encourage you, when a question comes up, just put that in the chat, and Astrid's going to help me with monitoring those questions. After we finish our session, we will be moving to different breakout rooms, and each of the speakers, Kevin has to leave early, so we'll have 3 breakout rooms, and you will have the opportunity to choose which of those breakout rooms you'd like to go in to have some further discussions with our panelists, with our speakers. So today we've invited Abbas Ali, who is from ATCO Gas. We have Justin Gregoire, who is from ARC Resources, Kevin Krausert, who's from Avator Innovations, and Gary Millard, who's from Suncor. And so what we're going to do is just one at a time. We'd like you to introduce yourself, tell us a little bit about yourself, and then go into what are the current problems that your sector is really facing. And what I'd like to do is I'd like to start off with Kevin. Hand it to you, Kevin.
Perfect. Well, thank you so much for the invitation at this important conversation. So Kevin Krausert, CEO and co-founder of Avator Innovations. We work inside heavy industry and oil and gas in particular around unlocking energy transition solutions for commercialization, scale, and investment. And so I just want to thank you guys for the invitation. Entrepreneurship is a rare gift and a particular passion of mine, but you're bringing about important change to the world, and want you to all know that you've got my support. So when Stephen asked me to speak about real world energy innovations and pressing issues I'd worked on, I thought long and hard about a specific example. You know, most of you probably know me from Avator, but I spent 20 years of my life working at Canada's largest privately owned drilling company, 6 years of which I had the privilege of serving as the chief executive before starting Avator. And so I look back at my previous job, and most of the projects were highly capital intensive. And so I was trying to find an example that could really, I think, bring together many of the threads around energy systems change and new technology implementation that probably will resonate with this group. You know, so I think we all know that, you know, the traditional oil and gas industry, and as a result, the drilling industry is facing, you know, unprecedented disruption, not just from an energy transition perspective, but also increased demands around performance, cost of production, so on and so forth. So in the 2015-2016 sort of era of the drilling industry, oil prices were collapsing, but there was also a real urgent need to bring about increased efficiencies inside the drilling industry. And there was increasing demands on drilling equipment. We were pumping higher pressures. We were operating so much faster. There was increased demands on people. You saw, you know, a workforce that had gotten really used to one generation of equipment being forced onto another generation of equipment. And this demand march was really leading towards automation in the industry that we couldn't have had before. And I think that there's a lot of sort of quick wins the industry can still accomplish on automation, both from an entrepreneurship perspective as well as a decarbonization and efficiency gains. So I was looking at these, you know, $25, $30 million pieces of equipment that we had. And, you know, to understand a drilling rig, you've got basically something that turns, something that pulls and pushes, and something that pumps. And these pieces were not communicating, and you had a human controller sitting trying to manage all of these different pieces of equipment in increasingly faster ways. And so the world was really thinking about automation, but they were thinking robotics. You know, how could we get people out of the way? How could we put some sort of robot to move the heavy equipment around and optimize it? But the challenge was every time the industry would go and roll out one of these pieces of equipment, it actually made it slower because it was hard to get a robot to operate this heavy equipment as quickly as a well-trained operator. And so in my mind, it became clear that the equipment actually, the way the equipment communicated with each other was really where the optimization was going to happen. So we came up with process automation solutions. How could we connect each piece of equipment on the rig to an operating system? And then this would open up a whole suite of optimization software, faster drilling, better adjustments, artificial intelligence, a whole world. So we went to a variety of operators, but we convinced ConocoPhillips to believe in this dream. And so we started building the first of these rigs. Then the University of Calgary and its Integrated Drilling Research Center started designing apps. There was, you know, all of this incredible data that we could, you know, integrate to optimize parameters on a microsecond basis. So then we go and roll it out. And the challenges in the drilling industry, which is pretty reflective, I'd say, of any energy industry or energy system, is you've got 17 vendors involved in any operation, all of whom are operating on the day rate model. So the traditional model of how this new technology gets rolled out is operator comes up with some new drilling app, goes and rolls it out on the rig. The driller has no idea what he's doing. Service company has multi-million-dollar tools down the hole. something breaks, everybody goes on day rate, and then let's never try this again. So it's not just that a lot of the contracting models that exist in the energy industry, which are perfectly designed for specialization and efficiency, it's not that they have no incentive to innovate, it's that they sometimes have a direct negative incentive to innovate. So how could we work together to actually be able to bring these systems about and create value for the technology and the research that was being done in a capital intensive, safety critical, and highly regulated business? So we brought everybody to the table. We shut down the rig and brought the researchers, the drillers, the directional drillers, the engineers, all to the table to really start working towards a single unified goal around technology implementation. And the results were pretty incredible. We designed some of the first automated directional drilling software that ever existed anywhere, driving efficiency gains up to the sort of 40% number. And when you had everybody rowing in the same direction, it was pretty remarkable what could happen. So in short, my big takeaway from this, and the reason I bring this example up is when you're looking at energy entrepreneurship and technology implementation in such a capital intensive industry, such as energy, you have to look at the system's complexity to be successful. Understanding who the stakeholders are that can advance or derail your success, and understand and create value drivers for everybody to row in the same direction. So in short, it can be a long road, but it's worth it. But understand who the stakeholders are at the table and you'll get there.
Brilliant, Kevin. That was really beautifully articulated. Thank you so much. And again, just reminding people, please put your questions in as we're going along so that we can really stimulate the discussion that we're going to have at the end. So thanks so much, Kevin. We're going to now move on to Abbas Ali Beg.
Hi, thank you, Shannon. Thank you, Foresight, for this opportunity. My name is Abbas Ali Beg. I'm a senior engineer with ATCO in the technology development team. A little about ATCO, if you guys aren't familiar, we're a globally diverse energy, modular construction, transportation, land development, and utility company. We have operations globally, and we're based out of it's an Alberta-based company. I work on the utility side. So I've been with ATCO for the past 10 years, primarily on their natural gas distribution side of the business. I'm an engineer. I have my bachelor's and master's in mechanical engineering from the University of Calgary, and am also a certified energy manager. I've had a number of different roles at ATCO, ranging from all on the natural gas distribution side, ranging from planning, designing, operations, construction. And in the last, I want to say maybe 3.5 years, I've been more involved in their R&D innovation group, managing the low carbon technology portfolio, and really trying to answer the question of how do you decarbonize the natural gas grid? We're doing a lot of discovery, incubation, and acceleration, commercialization of low carbon technologies. More of the focus for the team is on incubation, testing low carbon technologies. So we look at everything from hydrogen and RNG generation to micro scale carbon capture technology, as well as end use technologies such as gas heat pumps, micro cogeneration systems, hydrogen fuel cells, and hydrogen end use appliances, everything from cooktops to your boilers and furnaces. So the topic that I'd like to put out today, before I give you some background on the topic, thank you, Gary. I use a lot of acronyms. So if you have questions about acronyms in general, please put them in there. So the topic is, the question that I'd like to pose is hydrogen generation using pyrolysis yields carbon solid, so carbon black. And there isn't a real large use case. I say large because there is a use case, but there isn't really a large use case for carbon solid. How can we create an industry around carbon solid? And for those that don't know much about the pyrolysis process or hydrogen generation, nowadays there's a rainbow of colors of hydrogen. And I found 8 when I was doing a little bit of research early on, but you can get anything from brown, gray, white, yellow. For our conversations, we'll keep it to green, which is hydrogen generation through renewable energy and electrolysis, and we'll use blue, or I think turquoise is the right color here, where you're using natural gas, you're using thermal cracking of natural gas, you're using pyrolysis, everything from microwave energy to just heat, molten metal to generate hydrogen, and the byproduct is carbon solid. So there's an advantage over the blue hydrogen, which is sequestration, capture, and transportation of CO2. So now you don't have the CO2, you have carbon solid. But the problem happens is, what do you do with that carbon solid? There is an industry, not to say there isn't. I mean, carbon solid, there is an industry. Tires is the one that comes to mind. But a lot of these startups that I work closely with haven't been able to really identify the cost of carbon, like the value. The value of carbon could range anywhere between $400 from some startups. They claim that they can sell their carbon black for $400 to as much as $12,000 per ton. That is all per ton of what they can market their carbon black to. So there's uncertainty. That number just tells you there's uncertainty in the market as to what you can value the carbon black as. Currently, so the traditional method for carbon black generation is it's called furnace black, and there's thermal black. So thermal black, like Anna just described, is essentially the production of hydrogen. You get carbon black out of it. That doesn't account for much in the industry. Furnace black, which is basically they use cracking of heavy oils, and it's the most common process. 98% of the carbon black today is generated through furnace black. And generally 70% of the carbon black is used in the tire industry. 20% is non-tire essentials, and you can say 10% is just specialty rubbers. Production of carbon black is 14 million tons. And there's 5 producers that make 60% of it, and they also control the price. So it's a tight market to get into, but the question is, what do you do with the carbon black? Is there a value? Is there additional value, call it beyond the tire industry, that you can tap into?
Thank you so much, Abbas. That's a great one. Well, we can think about that as we're moving on. Thanks so much for your comments. All right, so now we're going to move on to our third speaker, Gary Millard. So please introduce yourself and present your problem.
Sure. So my name is Gary Millard. I am in the sustainability group at Suncor. So Suncor, hopefully most people know it, but if you're not familiar, it's a national energy company that is, well, it's a Canadian energy company. It's not nationalized, it's publicly traded. But we're an integrated oil company. So most of our production comes from the Canadian oil sands. We operate a number of refineries in Canada, one in the US, and we are the owner of the Petro-Canada retail brand. So really it goes taking hydrocarbons out of the ground, refining them, putting them out to the market. We also have, we operate the first ethanol plant for fuel in Canada. So we manufacture ethanol for biofuel blending with gasoline, and a number of wind farms for renewable energy and power from cogeneration as well. And so we are really trying to position ourselves as an energy company, especially in this energy transition, of course, largely based on our hydrocarbon history. So, of course, my role is Senior Advisor for Energy and Climate Change. And so I'm looking at how do we improve our operations, how do we reduce the carbon intensity of our actual operations, but also where is the energy market going, right? We're not the only ones that want to reduce our carbon intensity, our customers do as well. And so that's really what I want to talk to you about today, is that low carbon energy market. Now, I want to remind you, as a large company operating a number of different facilities in different geographic regions, different parts of the value chain, we are always interested in a whole lot of innovation and technology development. So don't let my pitch to you on this one topic dissuade you from looking into other areas for optimization. But I thought the angle that might be a little bit different is Suncor is looking at ways to grow and develop low carbon energy products to support climate change action, support decarbonization of our energy system. And one of those that's particularly interesting for us is the hydrogen economy. Now, the challenge is that we really don't have a hydrogen economy today. In Canada, and in fact, Suncor is one of the producers, we actually manufacture a lot of hydrogen, most of it through steam methane reformation. As Abbas was just talking about, there's different ways to manufacture it. Most of what's produced doesn't connect to carbon capture. That technology is there, it's coming out nicely. The challenge for us is right now we use hydrogen as a process chemical in our upgraders, refineries, that sort of thing. But what we would like to do is offer it as a low carbon energy product. And the issue is there's not a lot of uptake for it right now. And so how can we understand and even foster and support the development of hydrogen as an energy product? And so that's the question I want to give to you. It's a very broad question, but hopefully it'll appeal to a number of different researchers out here. So there is definitely a need for research and tech development in new technologies. Hydrogen fuel cells, really understanding how they can be deployed for heavy duty vehicles, for locomotives, marine vessels, aircraft, it's just to name a few. There's also using hydrogen as a combustible gas, right? Displacing some amount of natural gas in our natural gas grid. But there's questions around that one as well. So there's all sorts of tech development that's needed. But there's also a lot of research. So we don't necessarily always need patents and startup companies selling products. There's a lot of information. There's a lot of knowledge that needs to be developed. Some of that can be proprietary, some of it's commercializable, but some of it's just pulled from peer-reviewed literature, primary research. Some of it are meta-analysis, that sort of thing. For example, Abbas talked a little bit about producing hydrogen, but how do we store it? How do we transport it? How does it get used at the end? And so things like if we're manufacturing a large quantity, can we store it in underground reservoirs? What does storage in geological reservoirs, salt caverns, gas reservoirs look like, right? What reservoir characteristics or properties are helpful for hydrogen storage? What about leakage? What about mixing with other fluids? What about reactivity? Right? These are things that we need to understand before we can commercialize that, and that's valuable research and valuable information. Transportation is a whole other realm. And then I want to talk about the end use. So using it as a energy product means that we either need to put it through a fuel cell or burn it. If we want to burn it in a blend it into a natural gas stream, how can we transport it through the pipeline networks? Right? You've got all sorts of questions around leakage rates of various pieces of equipment or various materials, embrittlement of metals. There's some really good research going on. Sometimes what we need is somebody to bring it together to make it meaningful for a commercialization process. So, we'll have to submit an application to the regulator to commercialize or to implement some of these things. And it would be very helpful to have relevant peer-reviewed literature that we can point to that says, regulator, this is what we know about the current state, and this is why our application is valid. Then there's the whole hydrogen fuel cell side of it, and how it can be deployed, what concentrations can be used, what are the different mechanisms to connect stationary fuel cells to the grid. There was some really fascinating technological development and research needed to make decisions. And those are both commercial and regulatory decisions. And so that's really the perspective I wanted to bring today, is have you think about the market that we're selling into, not necessarily the process that we're using to actually come up with a product. And I encourage you to look for the commercial applicability of any of your academic work. There is actually a wealth of that out there. A few good places to look for: company sustainability reports. They'll often tell you where R&D is focused, where tech development is focused, and some of the problems that they're facing. Sometimes understanding the commercialization, the dollar value side of it, can come from annual reports or quarterly announcements, quarterly reports. So sort of understanding who might be a target audience for your research, and then going to their publications and just paying a little bit of attention to what their business problem is. You might have a technical or an academic solution, but the reality is they may not have a technical problem. They may have a business problem to which they're looking for a technical solution. And so understanding it through their lens would be helpful. That was really the prompt I wanted to give you today. I encourage any questions you might have there.
Thank you so much, Gary. That's a wonderful layout of the problem, looking at the business problem and also what the research needs are. Thank you. Now we're going to move on to our last speaker, who is Justin Gregoire. So I'll turn it over to Justin now.
Perfect. Well, thanks so much for having me on this panel. Yeah, my name is Justin Gregoire. I am an emission reduction engineer at ARC Resources. Being the last presenter, I'll try and group together my three previous folks, their comments, and trying to wrap it all up. But first off, for those that aren't familiar, ARC Resources is a 25-year-old Canadian energy producer. We like to own and operate all of our own assets. So, and most recently we had a strategic combination with 7 Generations, if anybody's familiar with that company, which made us the 3rd largest Canadian natural gas producer. So that's something that we're very proud of, and continue to try and produce the cleanest energy possible. So kind of on that note, we've always been evaluating emission reduction opportunities within the organization, and have had quite a lot of success, especially with electrification in some of our Northeast BC assets with the BC hydro grid. But one problem area that continues to arise is heat. So all processes require quite a lot of heat, whether that's natural gas processing, whether that's oil sands operations, whether that's even other industries such as cement or heavy industry. So trying to find a economic solution for reducing our emissions associated with heat is something that we continue to kind of scratch our heads at. So there's been a few ideas that have been passed around by my previous presenters. You got Kevin mentioning, process improvements and automation and those types of things where you can, manipulate things ahead of a process requiring that, machine learning type aspects. Abbas has mentioned, the hydrogen piece a little bit, and, the carbon aspect. So, is there carbon capture opportunities where all of a sudden you can take that carbon, have a marketable solution or market for that product. And then Gary obviously mentioned, the hydrogen piece. Do you generate hydrogen, use hydrogen for your heat supply, therefore decarbonize that front? There's obviously other opportunities. Electrification is obviously one, although, I'll go back to my comment on economic solutions. I'm sure everybody can kind of do some quick calculations on energy demand and realize that electricity may be a challenge for heat. So yeah, just trying to wrap up all 3 of those previous presenters in trying to find a solution, an economic solution to reduce our heat demand. And I'll maybe just throw out a few numbers before I pass it back to Shannon and she can start grilling us with some questions. But roughly 25% of ARC's combustion emissions are directly associated with our heat demand. So it's not a small amount, and I would assume, and maybe Gary can comment on this, is that some other operations such as refineries, oil sands operations, things like that, may even have a higher demand for heat and higher emissions associated with that. So yeah, with that, Shannon, I'll kind of pass it back to you unless you got any questions for me right off the hop.
Wonderful, wonderful. Thank you so much, Justin. So we've actually got a large number of questions that have been coming through for all of our speakers, but I thought I would just start off with just making a comment about all the presenters that we've had. I've noticed that there's a bit of a trend in what you've presented, in that we need to really be thinking carefully about not only the technical solution, but is there actually a business case for that? And really what the pain point is and the driver for that, and whether, and in some cases, you have to really be thinking about a new innovative business model. So Kevin was describing sort of the day rate model and how we may need to innovate from that, because the way people used to do things, if you're now making it more efficiently, you're bringing value in a different way. Abbas was talking about where is the added value for carbon. So now you're generating this new product, but have you figured out how you're going to make value out of that, and what those markets might be and what those supply chains might be? And then Gary has also been talking about, we need to also understand that regulatory demand. What is it that the regulators need to know in order to actually create the market? Because if you can't actually get regulatory approval, there is no market. And there's a real opportunity there to create new knowledge from university research or primary research in these areas that could provide the information to get that regulatory approval to help with the energy transition. And then we've had Justin move on to talk about the need for these economic solutions, that we need to be having our eyes open, thinking about what is it that the customer needs, what are the systemic changes that we need, and how can we include all of those different stakeholders. So I'm just going to open the panel up to ask if you have anything that you'd like to comment on sort of these commonalities that we've seen between all the 4 presenters. And maybe I'll put Kevin on the hot seat first to sort of respond to sort of my summary there.
Yeah, no, I think that was a great summary, and it was particularly fascinating for me to listen to a lot of the really strong technical innovations that the 3 other speakers were addressing. Getting to your point around kind of the systems change of how complex this all is, you know, I think one of the more interesting analyses of energy transition is potentially from the light bulb. Does everyone know the thread that's on a light bulb? How like you can screw any light bulb into any other one? Does anyone know where that thread comes from? It actually comes from a whale oil lamp. So Thomas Edison, previously the world was all lit by whale oil. Standard oil actually at the time was because it was standard spermaceti whale oil. And he realized if he was going to come up with an electric light bulb that was going to displace this, he had to use the existing infrastructure that was in place. So he came up with a thread where he could just put an electric filament in people's homes, and then they wouldn't have to change it over. And so you look at a lot of these different types of solutions, like, you know, the hydrogen solutions. Gary was talking about, well, what happens when you transport it? What happens if leaks? What happens with all these different things? You know, I think that looking at energy transition changes is you have to be looking at how you can integrate it into a system like Thomas Edison did on the light bulb. And so I think that encapsulates the work that a lot of us, you know, kind of have to be doing is who are the key stakeholders on any technology implementation. There's a lot of fantastic technology implementation or technology out there that never gets implemented because it interrupts this different system from a regulatory perspective, from other causes. And what's the business model that's going to make it work? As you know, I'd say my high level thinking to try and synthesize the great questions the other speakers have mentioned.
Brilliant, Kevin. So thank you so much for giving that example. And I'm actually going to throw the ball over to Gary, because Gary, one of the things you brought up was regulators. And one of the challenges that Kevin has just talked about is you need to get adoption, and you've got to make that transition as easy as possible. And there's all these challenges around adoption of new technologies and new approaches. And maybe you can make a comment on some of those challenges that you've seen, and what are the things that people should be focusing on and thinking about?
Sure. Yeah, regulations can do a number of different things. In a lot of cases now, especially what we're seeing with you know, national commitments to the Paris Agreement, are governments creating regulations or policies that create incentives for transition. And so understanding what we're being pushed away from and what we're being pushed towards is really important. You know, so some of the things we're looking at are, you know, there's incentives around making biofuels, let's say, as a drop-in replacement for internal combustion engines. But then you've also got regulations that are banning the sale of internal combustion engines. So, you know, now business has to take a look and say, okay, well, what's the runway? What's the lifespan of a biofuels project? Because there's these competing regulations out there. Where is the growth happening? Understanding some of the complexities and the interplay between some of the regulations is really important. Another part of what regulations often do is protect the public from sort of deployment of certain technologies. And the challenge around that is, as the technologies change, the regulations don't always keep up quickly enough. And so understanding some of those challenges and barriers, you know, for example, electricity sales, right? We've had this, you know, this excellent electricity grid for well over a century. It's worked out well. The regulations have developed so that there's protections in place for the consumer, such that retailers have certain obligations, and it's, you know, to become a power retailer, you have to go through certain processes. The challenge now is, you know, when you're selling somebody power at their house, that was fine, but if you actually go to sell electricity to charge an EV, you actually can't become a power retailer that way. So you can't actually sell an EV customer electricity. You have to give them electricity for free and sell time at the station. Of course, now if you're charging at a lower rate, that's a disadvantage. You're paying more for the you know, the same amount of electricity. And so understanding that some of these regulations, well-intentioned and perhaps even very effective at the outset, aren't keeping up with the technological changes. And so, understanding not only what regulatory change needs to happen, but how can technology be developed so that we can support that regulatory change, right? What type of metering might be needed to facilitate trade quality, right? Financial trade quality, dispensing of electricity. What types of protections are needed when we're handling hydrogen gas as opposed to natural gas, pressure vessel regulations. These things touch on so many different parts that just understanding, is there a barrier there or not? And if so, is there a regulatory solution, is a technical solution? So, not that it's every researcher's job to understand that, but as was mentioned, realizing that a single technical solution doesn't automatically solve the problem. That you're now talking about commercial deployment, you're talking about regulatory acceptance, you're talking sometimes about social innovation, and connecting into these broader realms is a really important part of it.
Very good, Gary. And actually, I think the piece that you've brought up is that the researcher doesn't necessarily have to focus on that, but when you get to the stage where you're moving from primary research to applied research and research translation, that is the point where you're now looking at that knowledge exchange piece. When you start to have to look at your stakeholders and understand what the business case is. And I wanted to turn it over to Justin to have him comment on that, because one of the things you talked about is having economic solutions and to think about what that economic piece might be. So if you have these regulatory barriers in place, there's no market. But the opposite side of the coin is that if you can get that regulatory engagement, you can create a market. And if you're careful and innovative on how you do that, you could be first come to market. So maybe I'll have just have you respond to what Gary and Kevin have been discussing.
Yeah, no, absolutely. Like obviously regulations will tend to push people over that hump a lot quicker than incentives, i.e. carbon tax and those types of aspects. I know there's been a few discussions around hydrogen and that piece. We have the distribution system now. There's questions as to whether that can handle hydrogen and those aspects, but there's a question by Robert I'm kind of seeing in the Q&A around what's a bigger challenge, producing that hydrogen or finding a use for that hydrogen. I know the question was kind of directed towards Gary, but I would almost comment on the use of hydrogen is our biggest challenge. Hydrogen production has been around for quite some time at the scale where it needs to be to decarbonize the entire system. Probably, it's not quite there yet, obviously. But I would say it could get there rather quickly if that's where the demand was. And I really want to comment on the demand side of things, right? Today, for a company to produce, whether it's blue or whatever rainbow of colors of hydrogen that you want to generate, the demand out there, it just isn't there. We can't generate hydrogen at a large enough volumes for it to be economic to be able to find an end user that wants that large volume. Now, if we start putting that into the distribution system, the existing distribution systems, and it starts being used in households and other industries, that's great. That's eventually going to push everybody in that direction. Now, whether that's from regulatory aspects where a regulator states go forward, 30% of your entire distribution system has to be able to handle hydrogen, or whether that's a downstream market demand where at the end of the day, end consumers are asking for that blend. So yeah, purely talking from an economic standpoint, that the quickest movers are going to be the ones that can find a downstream market and an end user that can justify putting a large amount of capital in place. So yeah, on the research side, I would definitely recommend taking just a first step before you kind of get into the research is what's the long-term demand for this. And Gary brings up a very good point on the EV aspects. I was not aware that they can't charge on a per megawatt or kilowatt aspect. So it's kind of an interesting perspective.
Thanks so much, Justin. And now I want to actually turn it over to Abbas, because we've what we haven't sort of talked about is when there's sort of a byproduct, and you talked about carbon black. So you have an opportunity to adopt to help do the transition towards a hydrogen economy, but you're also generating something that could be quite valuable, but you haven't quite figured out what that value might be. And maybe you could talk a little bit about what those opportunities are to sort of have two value chains sort of produced, or what those opportunities are, and sort of respond to what Justin and Gary and Kevin have been discussing about us.
Thank you, Shannon. So I know there were some questions there. I was just trying to read all the questions and the answers at the same time. So there's currently a 73 million ton production of hydrogen globally, right? Or that's what the need is right now. And I mentioned the 14 million tons of carbon black that's required as well. So if you can basically kill two birds with one stone, like you're generating the hydrogen for decarbonization purposes, plus you have this carbon black that you can offset, it's a key. Now, the problem, one solution to the problem here is, what do you do with the carbon black generated? I think someone was asking about the mechanical properties as well. They're not as strong. So mechanically, it can't withstand that many stresses as compared to the furnace black that's used in tires at the moment. So there are some quality issues with the carbon black that you generate with thermal cracking. So understanding those, but one solution is you just bury it. You just landfill it, right? And you have hydrogen, but you just landfilled a bunch of carbon to offset your to decarbonize the natural gas grid, for example, right? Or your energy requirements. But that's probably the worst scenario. Like, I mean, you're trying to create something that is, you have this value and you're like, well, I don't know what to do with it, so let's just bury it. Doesn't make any sense. So if we can create value in it, it'll be important. I was gonna more talk about this example, and Gary likely knows about this too, Clean O2. So it's a technology that basically you take flue gas, right? It can attach onto any flue gas off of a natural gas combustion appliance, and it generates potash, which is used in soap. It doesn't need to be added into soap, but it's added into soap for the purposes of capturing it. You have created a use for the CO2 that was in gaseous form to be a solid. Now and a useful product. Could carbon black be used in, for example, this chair that I'm sitting on, or this table, right? It would be landfilled at some point, but could it be used here as a value add product and replace something that would have been more carbon intensive to create? There are companies that are looking at generating electricity, so a direct carbon fuel cell, for example, of the carbon. So there's a lot of opportunities. We just need to tap into the right one that creates the most value and creates that value chain, rather than, well, okay, well, I have this potentially valuable product. Well, we know it's valuable. Someone's paying money to generate it. It's used in the entire industry, and we can just landfill it. So looking for those opportunities would be ideal.
Excellent. And I think one of the things you brought up, Abbas, is the importance of thinking about industrial ecology. So if we can think about what the waste streams are that are being produced, and there's a cost to get rid of the waste stream, as you said, if you just landfill it, if you can add more value to that, then you can magnify what the impact is of that. Now, we've had a large number of questions that have come in over the panel that we've had, and I'm actually going to turn it over to Astrid, because she's been monitoring it, and we'll go through as many of the questions as we can get to. For those of you that we don't get a chance to get to, we're going to ask each of you to unmute yourself and restate your question. You'll have a chance to ask those questions in our breakout sessions, which will start in about 12 or 13 minutes. So Astrid, would you mind indicating who the first questioner is?
So we have a first question from Sashindra. Would you like to unmute yourself and ask your question to Abbas about the technology readiness level?
Yeah, sure. Dr. Abbas, I wanted to know about the technology readiness level of pyrolysis for commercial hydrogen production. I wanted to know whether there are middle to large scale pyrolysis plants already available for producing hydrogen on a commercial level.
Well, thank you for the honor. I'm not a doctor. So at the TRL level, associated with a lot of the pyrolysis technology that I've looked at is early. Like, I mean, we're looking at 5. They've done some Brent scale studies. They're in that, they're pre-prototype. So they're looking for field demonstrations. A lot of these companies have approached us because ATCO currently has, in ATCO Gas Australia, we have a clean energy innovation hub where we are generating hydrogen using electrolysis and blending into the system. In Alberta here, northeast of Edmonton, Fort Saskatchewan, we're embarking, started the project, of blending 5, and it'll go up to 20% hydrogen blend in that community, feeding to around 2,000 homes. And we're looking at a lot of different options. Right now, all of the pyrolysis technology we've looked at is early. So we're looking at anywhere between TRL 5. Some claim they're near the 6 and 7 and ready for some sort of a pilot demonstration, and they've done them at different universities. So to answer your question, no, there aren't any. However, a lot of innovators right now and industry, for example, within ATCO and Suncor and the likes, we think that turquoise hydrogen could be the sweet spot. That electrolysis, awesome green hydrogen, right? You can't get better, but the cost is really high. And then you have the other forms of hydrogen. There's gray hydrogen, but you emit a lot of CO2, and then you have blue where you're capturing the CO2, but there's a lack of infrastructure to transport the CO2 once you've captured it. Or what do you do with it? So carbon solid and pyrolysis, we think that turquoise hydrogen could be the key. And that's what we're really here we're hoping that would be proven in the next 5 years or so. So TRL 5 is where I would gauge it at, and there aren't any mid to large scale at the moment that I know of.
Another question, and actually related to turquoise hydrogen, from Stephen Wilson. Steve, do you want to go ahead and ask your question about the tons of carbon?
Yeah, sure. Abbas, you mentioned, I think you said 73 million tons is the current use of hydrogen in industry, right? But if you actually start replacing 20% of the natural gas grid, what does that use look like? You sort of said there was 14 million tons of current demand for solid carbon in tires and other applications. Do you end up making like 50 or 100 million tons of carbon, right? So there's actually this massive availability beyond current demand, or?
That's absolutely right. So we can saturate the carbon black market very easily. That being said, I had mentioned the mechanical properties of the carbon black, that you can't just replace it right away. But let's say there is that case that you can saturate the market very easily. For every kilograms, like some of the technologies we've looked at, for every kilogram of hydrogen generated, you're gonna get 3 kilograms of carbon solid. It's a very dense material. So you can saturate the market very easily. So hence there has to be a use case, or we would eventually be looking at landfilling it, burying it, which wouldn't make sense. Gary, you had a question, or you had a comment.
Yeah, I completely agree with the current market description that you're talking about. But the beauty with some of this research is if you can connect it with other activities, you can unlock markets. So carbon black is roughly near pure carbon. If you combine it in the right way, you can turn it into graphene. Well, the current market for graphene is tiny because we're producing it at square centimeter scale. But if we could ramp that up to industrial scale, graphene is extremely strong, extremely light, and very high electrical conductivity, which means it would be great for power transmission lines. And if you talk about replacing the aluminum power transmission lines around the world with graphene, your market is massive, way bigger than the current carbon black. So sometimes, we can sort of connect a few things together and say, well, what if? And yeah, that market won't appear next year. It probably won't even appear in 5 or 10 years. But 15, 20 years down the line, that could actually be a big destination for it and create a demand for carbon black, outstripping even the current production methods.
We have another question from Mohammed Islam about the price on market for hydrogen. Mohammed, do you want to go ahead and unmute yourself and add your question to Abbas?
Hi, Abbas, Mohammed here. In fact, I'm collaborating with UBC for some pyrolysis technology, and my company's name is Turquoise Hydrogen. So the question comes what's the incentive you get when you just focus on a hydrogen market, the extent of hydrogen market? When we see 2050, the market's going to be 1.5 trillion. Would that put more focus on pyrolysis or turquoise hydrogen that way?
Well, at least I got the color right. So, I think you're absolutely right that, I think at the moment, yes, there's a lot of talk on hydrogen. I'm talking to a lot of academia here, and I talked to academia from across Canada and in the US, and apparently there's a lot of funding available whenever you bring hydrogen into the solution, right? So there's a lot of talk about hydrogen because industries express interest as a way to decarbonize. Like, I mean, we can check off all of our boxes when it comes to scope 1, scope 2, and scope 3 emissions altogether, right? So it provides that easy answer. It's like, how do we do it logistically? 2050, yeah, I mean, we're looking at that. We have that hydrogen blending project going on right now that by this time next year, we'll have a community in Alberta that would be fed off of 5% hydrogen. Objective is to decarbonize. And this is one way to hopefully decarbonize the natural gas grid and provide decarbonized energy to customers that would be affordable. And we're not going to be breaking the bank on providing energy and heating our homes.
Thank you.
Next up, we have a question from Chester Upham about carbon production beyond carbon black. You want to go ahead and unmute yourself, Chester?
Yes, thank you very much. And thank you to all the panelists for these great introductions. And so my question was really to Abbas, although I guess Gary touched on it, and this is looking at carbon beyond the carbon black. Abbas, you mentioned carbon black as the main carbon you were looking at and thinking about in terms of pyrolysis technologies. But of course, there are some very low TRL studies on some of these other carbon morphologies, other carbon production methods, and some are scaling up. And just wondering your take on those and favorite technologies there, and where you might see the research and development on some of these other carbon fibers, carbon nanotubes, graphene type of carbon.
So I see there's value in all of it, and that's why I think that if we were to look at carbon from that entire value chain from production to end use, it would be is going to be very critical. Whether like I gave this example of, could there be, like right now, the dust that I have, it's made out of some MDF material. Could it have a use where we could use that carbon, and instead of getting this MDF, we can incorporate some form of carbon in it to take advantage of that material that's being generated. So I think that use cases across the board of carbon, whether it's graphene, carbon fiber, and the likes, is going to be very large. If we can incorporate into building materials, that even adds an additional value, that now you're not sourcing those materials from maybe carbon intensive processes, because you have this byproduct. How do we utilize this byproduct? Understanding the discovery, incubation, and acceleration of the technology, commercialization of the technology early on is going to be very important, because you could have the best technology or best product, let's say, but if there's no use case for it, it's just going to fall short. So there has to be a fit with what the customer is looking for. You're essentially creating a rather than a want, more of a need. That this customer needs this thing. When you go buy your building material has, for example, carbon incorporated into it, right, as an offset. So having an understanding of that discovery of what the customer is looking for, that pain points, the gains. I think some of you may have gone through the business model canvas, and understanding all of that entire value chain of how can we use this value add product would hopefully solve that problem that I posed. What do you do with the carbon black?
I was just maybe going to add to that. Obviously there's been a ton of research done on converting CO2 to a useful product. X Prize, I'm sure everybody's familiar with. But not only thinking about the waste product, but also where is that waste product being generated and where is the use? If cement is a great example where there's a lot of CO2 emitted. If you take that CO2 that's emitted at that source and re-inject it into the process and to create concrete, huge value chain because everything is so close. But if you're trying to capture CO2 somewhere that's 100, 200, 300 kilometers away and trying to bring that waste product over to a use, that's when things start degrading from an economic standpoint. So the generation versus use is also something that has to be kind of kept in mind along the value chain.
Yeah, I'll reinforce that one just a little bit. A lot of times you get this idea or this great idea for commercialization, but it's in the wrong geographic region. And so, in Alberta, carbon capture probably is the classic capture of CO2 and injection of CO2 is probably great because you've got these point sources, you've got great reservoirs to sequester. But if you want to do that in Eastern Canada, you don't have the same sedimentary reservoirs. And that's where, the turquoise hydrogen, the manufacturing of carbon black, either you've got a manufacturing sector there for it, or at least you can landfill it, but you don't have this CO2 product or CO2 side product, waste product that you can't put anywhere in a geological reservoir. So yeah, sometimes the best idea is pitched in the wrong place. And if you can find the right geographic place for it, it might be a better fit. Great point,
Very
Justin.
Good. Very good. Well, thank you so much to all of our speakers. Kevin had another commitment at noon, so he had to leave early. But what we're going to transition to now is to moving to different breakout rooms, and you'll have the opportunity to select going with Justin, with Abbas, or with Gary. And we have different facilitators that are going to be helping us as well to run those questions. So you can select who you'd like to go for, and you'll have a chance to take the questions that you haven't had a chance to ask in the open session and ask those within your breakout session. And we have Nefret El Masri, Jessica Urbach, and Sahan who will be helping to facilitate those breakouts. I believe Astrid is going to set those up now. So again, thank you so much to the panelists, and thank you to the audience for having so many great questions. And please take a chance to ask those questions in the remaining questions in your breakout. Over to you, Astrid and Stephen.
Thank you very much, Shannon. I think the breakout rooms are open. If you can see on the bottom of your screen, there's the little breakout room button there. Mine has, red 11 next to it for some reason, but you should see that it's right next to the reactions. You can go there, click on that, it'll pop up, and then you can choose the rooms of Gary Millard at Suncor, who's again talking about the utilization of hydrogen, some of the research requirements around how high can they mix those. Justin Gregoire from ARC Resources talking about their need to decarbonize the heat they use in their processes. And finally, Abbas Ali from ATCO Gas talking about what are they going to do with all the carbon, all that wonderful solid carbon that they have. So there's a few people still here. If you would like or have any challenges around the breakout room, please drop a message in the chat and I can move you manually over into any room you like. I hope you had fun in your breakout rooms. I certainly enjoyed the discussion that I had in mine with Justin Gregoire and Abbas Ali, and I am sorely missing what words of wisdom spilled from the mouth of Gary Millard and the conversations you had over there. But I do want to mention, we will be doing this again in 1 month. On October 28th, we're going to come back, and we danced around the topic a little bit in our room, but we're going to spend the whole time on carbon markets. We've got Katie Sullivan from the International Emissions Trading Association. We've got Anna Stukas from Carbon Engineering, and they've got their project down there with Occidental based on the 45Q from the US government. I'm sure she has an opinion on that. Kai Alderson from Faskins, and Don D'Souza from the Climate Action Secretariat will also be joining us to discuss carbon markets, pricing, regulation. That'll be on the eve of COP26. So maybe we'll hear some predictions on what will be happening there, how the global carbon markets will impact offsetting for corporations, activities for the country, and how this will impact specific projects. So if you love those sorts of topics or you've mentioned them today, do tune in there on October 28th as we continue the conversation around carbon. I want to say thank you so much to our panelists, Kevin, who unfortunately can't be here, but Gary, Abbas, and Justin for coming and sharing some of the challenges that their specific companies and industries are facing that we can help them with, that will move the needle significantly, right? What do we do to enable the changes that we need? What technologies do we need? What business models do we need? What policies and regulations would be helpful? How can we help them make the changes we want to see? With that, thank you so much for joining. I'll let Shannon say a last goodbye from our friends at UBC, and I look forward to seeing you all in a month.
Fantastic. Well, thank you so much to our panelists, and thanks so much to their audience as well. We had a really stimulating discussion in our breakout session, and I think this is a lot of food for thought for moving forward. So thank you. Thanks for everyone participating.